to the question. That company C was responsible for approximately what percent of total sales in the sector in 2007? Okay, company C. Okay, company C over total. Let me assume that we have not seen this question before. So we know this, we have read this. C over total. Then we go to the question. So this is the question. So we can now focus on the question. C over the total. The next thing is we can then go to we locate the 2007. So this is the total. This is the 2007. The 2007 is we can now see we have 3 companies. So how do we get our total? How to get our total could be the next thing to ask ourselves. So how do we get our total in 2007? Okay, this is our total. Our total, this is here, here, and here. Okay, the next one is let's add some speed. Let's be careful. Total sales is in million. And what is C? Do we know C? Okay, C is the triangle. So C is the one up there. Okay, so C is approximately 120. So it's going to be 120 over 120 plus B is approximately 30, just a little above 30, and A is approximately what? Let me just be sure you are here with me. A is approximately what?
20.
A is approximately 20. Thank you. 120 plus 30 plus 20 is what?
170.
170. So we are looking at 120 over 170. 120 over 170. Okay. This is going with this. So we are looking at now 12 over 17. So what is 12 over 17?
70.1 about 20.5 exact. Preliminary 70%.
Okay. 07 what?
0758.
5. That's approximately 75%, right?
No, 07.
Yes.
058.
058.
So there's a difference between 7 and 5.
Alright, I've corrected it. So we have all this 58, which is approximately 70%. Oh, but okay, approximately 70%. So first, let's go and check the answers. If we get this any value close to this, of course there's a value close to that 70%. We select it and check our answer. Okay, so that is correct. You see, that is something that you do, because when I ask you, or you already said sum up, yes, find the total. Okay, now let's go to the topic of today. The topic of today, and the topic of today, we are looking at the next thing here. Let's say number properties. We're going to take these number properties. There are things so there are things we know, and we are going to be as fast as possible. Let me set the timing to 45 seconds, and the practice at just 5 minutes, so that will give us enough time to finish it. Let's start this session. You see here it said even odd addition rules. Odd plus odd is even. Anything they said here, in as much as odd and even number is concerned, it shouldn't bother you. I know pretty well that you know odd numbers. Example of odd numbers is what?
1, 3.
1. Yes, thank you. So whenever they ask this, the best thing to do is pick numbers, because if they're saying even plus odd is odd, you can just pick one, or even number 2 plus 1, 3. So 3 is an odd number, so you don't really need to bother yourself, right? So at least you free yourself. That doesn't mean that the human brain is limited. We can absorb all the information in the word. Even odd multiplication, you just do the same thing. Even times anything is even, odd times odd is odd, even times n, or even times yes equals even, odd times odd is odd. Okay, so you don't bother yourself. Okay, you don't bother yourself, no matter how they send it. Even if they said about square, odd square, even, odd, you just pick numbers, right? You pick numbers and repeat the numbers. Okay, so that's solved. So that's solve it, or that's solve it for you. Okay, so we wait for the next concept. Prime numbers. You see what is written here is that a prime number is a number greater than 1, because this is a concise note. You see, the sign there means a prime number is a number greater than 1. By the way, I sent you the video of yesterday. Did I send it to you? Of that class in the morning yesterday? Okay. Okay, so a prime number is a number greater than 1. Okay, but what is not added here is that a prime number is a positive integer, not just greater than 1. Okay, a prime number must be an integer. It's an integer greater than 1. Only factors are 1 and itself. 2 is only even prime number, the rest. Counting factors. So now this we need something here. What you mean by counting factor? You see that the prime factorization of 240 is 2 raised to the power 4 times 3 raised to the power 1 times 5 raised to the power 1. If you want to know how many factors of 240, you are going to add those powers. You see where the powers are now. When we start solving our own question, so we are going to focus on prime factorization. But just remember this. If you want to count how many factors, you do step 1, prime factorize, then add 1 to each exponent, then multiply the result. Okay, you can screenshot that. You also have the game, you can go back to it. The LCM is highest power of every prime in either number. This is divining it in a new light, right? The highest power. Or if you think about 12 and 18, the simpler way of thinking about the LCM of 12 and 18 is just to ask yourself, what is the lowest number now both 12 and 18 can divide? So that number is 36. The lowest number both of them can divide. But this also have this put here, that highest power of every prime in either number, every prime, the highest. The HCF is also using the prime. Is also using the prime idea. It said lowest power. That one is the highest power. This one is the lowest power of prime common to both. Of prime common to both. But in a simpler way, you also ask yourself, what is the highest number that can divide 12 and 18? And it's 6, right? Because I don't see any. I don't see any. I don't really see anything or anything faster in using the formula when the numbers are small. Okay, what is the GCF here means HCF, remember? So Americans called greatest common factor, so we call highest common factor. This is a very interesting math concept, that the LCM times HCF equals the product of the numbers. So let me quickly ask you, what is the LCM of 5 and 10? The LCM of 5 and 10 is 10, and the HCF of 5 and 10 is 5. You see, so 10 times 5 is 50, and so. Or what is the LCM of 12 and 4? The LCM of 12 and 4. Oh, that one is still the same thing. So I wanted to use 4 and 6. But just know that if you multiply LCM and the HCF of the same number, it will give you the product of that number. Here we have divisibility rules. Divisibility rules. In divisibility rules, all the numbers that end with 2 can divide them. All the numbers that their sum of the digits is can be divided by 3. 3 can divide them. 5, it ends with 0 or 5. 9 is the same rule as 3. 8 is the last 8 digits. 4 is the last 2 digits. And so on. Divisibility rules makes it easier to solve questions. Hardly anyone is going to ask you about it in the exam, but to solve questions, yes. What is the idea of remainder? Of course, 23 divided by 5 is 4 remainder 3. But what is not here, the one that is of interest is, so you see that 23 divided by 5, the remainder is what? The remainder is 3. How about 5 divided by 23? Because that one is not here. So 5 divided by 3. 5 over 3. Sorry, 5 over 23. 5 divided by 23 is 0 remainder 5. Okay? 23 divided by 5 is a normal. So we can think of what it is. Okay, so we can think of what is this. But 5 divided by, or what of 5 divided by 23? The remainder is 5. Trailing zeros and decimals. Trailing zero, it simply means the zero after. In 2026, this year, there is no trailing zero. In 2200, there is two trailing zeros. So the zero after. What is written here, that trailing zero equals 5 times 2 pairs? Because 5 times 2 is 10. So 5 times 2 gives us 1 0. Decimal terminates only if the denominator has 2's and 5's, or a combination of 2's and 5's. What do they mean by that one? Like 1 over 2 terminates, but 1 over 3 will not. Counting multiples in a range. Multiples in a range. See what this means. How many numbers are from 1 to 100? You see that is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's very easy. But if you say 10 minus 1, 10 minus 1 will give you 9, right? Is that not? Are you there? So 10 minus 1 will give you 9. You see that to get it correctly, it will be 10 minus 1 plus 1. 10 minus 1 plus 1. Why is this important? How about all the integers between 200 and 300, 200 and 500? It's not 500 minus 200. It will be 500 minus 200 plus 1. Alright, so we are back to this even number, which we already know. Odd squared equals odd. You just take any odd number like 3. 3 squared is 9, so nothing to bother. We can keep talking about the other ones. Like if you say 1 divided by 6. 1 divided by 6 will not terminate because the denominator is 2 times 3. Okay. That doesn't mean that a number will not terminate if is not divided by 2 and 5. But if it's divided by 2 and 5, or a combination of 2 and 5, it must terminate. Because if you say that, what about 6 over 3? So 6 over 3 is 2. Alright, so we are ready to begin this practice. So let's go ahead and practice. What is more important is not only this class. It is meant that you repeat this particular concept today before we take another concept tomorrow. Okay, so because if you repeat it, memorization or memory comes with repetition. So the more you repeat, they understand. But if you just want to do it now, it will now be like you are cramming. By the way, we still want to push to make sure we didn't fail. So I have some success, so that we are going to be, at least try to get more than 50%. I've started the quiz. Even plus odd. Be fast. Even plus odd is not even. Even plus odd.
It's odd, rather odd.
Which product is always odd?
Odd plus odd.
Are you?
Odd times odd. Odd times odd.
Okay. Which of these is a prime? Remember, no number can divide it except one and itself.
51. I think there are a lot of
You see,
No, 57 can divide itself.
you see those numbers.
47 can divide
You
itself.
see, when we talk about divisibility rules, you need to go back to it. That I want you to get certain things. You are totally certain, right? Imagine if you ask me now uh, to spell a name that's not a regular English name. I'll probably not get it. But if you ask me to spell my own native name, I'll be able to get it right. I want you to be clear about certain things. Know the divisibility rule, right? Know the divisibility rule. The divisibility rule 51 is divisible by 3 because 5 plus 1 is 6. Okay? Because 5 plus 1 is 6. 5 plus 7 is 12. Oh, 49, you know that 7 times 7 is 49. The only odd number here that we have not processed is 53. Right? Is yeah, 53. So let's move on. How many positive factors does 48 have? Now this is going to take us a little time. First of all, we have to do prime factorization. Prime factorization means write a number using only prime numbers. Just take it that simple. 48.
4, 6.
So you have 6 times 8, okay, and 6 is 2 times 3, okay, and 6 is 2 times 3. Let me take that out for want of space. Okay, 6 is 2 times 3. Oh, 6 is 2 times 3. 8 is 2 raised to the power 3. So let's 8 times 2 raised to the power 3 is 8. Now combining this again, so we have a total of 2 is a total of 4. 2 raised to the power 4 times 3 raised to the power 1. The next thing is we are not factors. Remember, we are still wrestling against time. So we add 1 to 4. 4 plus 1. We also add 1 to the 1 and multiply out. Remember the rule. Cannot always go back there and check. This will be 5 times 2, which is 10. So we have 10. We have 10 factors. LCM of 6 and 10. Let's be fast with this. We don't need to use that formula. The lowest number there, 6 and 10, can divide is 30. Let's be a little faster here because so we are wrestling against time. What is the yes, the lowest number that can divide both 24 and 36? You know, what? How about 12? The highest. Yes, now that is what it is. The lowest number that can divide 12 and 36 does not mean the lowest number that can be able to divide them is 12. It's not 4. Oh, I think I made mistake. Is the highest number that can divide 12 and 36? The highest number that can divide 12 and 36. The highest number that can divide 12 and 36 is 12.
Yeah, but you said this year the formula was saying this year is lowest. Why LCM is
No,
highest?
yes, no, is the highest number. That highest, where it is coming from, is the highest number that can divide, not from the pronunciation. The highest number that can divide 12 and 36 is 12. Okay. The LCM is so is 24. Oh, LCM times this is 24. I think we can take this 723s. Is it divisible by 9? Yes. 7 plus 2 plus 3 plus 6 is 9. Okay, our time is running, but I don't know if we can get another one. 58 divided by 7. Okay, remainder 2. Thank you. You got that one. Okay, 90%. Not bad. Alright, we still have a little time. We have got some things done, but we still have a little time. We can actually take another concept, make it very, very fast, make it snappy. So we can talk a little about it. Then you can go back to it. So let's take the next topic. The games. The next topic here is, I hope this will not kill us. The next topic here is, okay, this. Yeah, I'm not going to use, let's still use study mode, but I'm going to reduce the time. I will talk throughout the session with this. I don't. Also that this GitHub is also slow this morning. Okay, it's not about root and exponent. Root and exponent. I think we have alternative. We're supposed to have alternative to this. We're supposed to have alternative. And I also tried downloading this. This start session. So I will be talking throughout. Okay, so even something is not clear here. What's supposed to be here is s raised to the power a times s raised to the power b becomes s raised to the power a plus b. Okay, if you don't mind, I can split this, right? This is s a times s raised to the power b equals s raised to the power a plus b. Next concept. So I've taken this one, and these are basic math concepts you have. This is power to a power. Oh, I don't know whether we have missed the third concept that is division. So but this is okay. So this is power to power. A is here and b is here. So this becomes for us s raised to the power ab. So we can combine power to power. Simple. And all this you can investigate them using ordinary numbers. This one is s raised to the power negative n. This means reciprocal 1 over sn. Okay. And so this is how to write reciprocal. So the next concept coming in 1 second. 0 and first power. Anything raised to the power 0 equals 1. Let me demonstrate that for you. And there's also a concept I think we didn't write, which is s raised to the power a divided by s raised to the power b equals s raised to the power a minus b. Now think about 4 raised to the power 1 divided by 4 raised to the power 1. But we know that 4 divided by 4 is 1. But if you use indices, it's going to be 4 raised to the power 1 minus 1, which is 4 raised to the power 0. But we already know that the answer is 1. So anything raised to the power 0 is 1. That's where it comes from. So you can see here that only saying that s can also be, the square root of s can be written as this. Just like the square root of the fifth root of s. Okay? The fifth root of s can be written as 5 raised to the power s raised to the power 5. Wasting time. So s raised to the power 1 over 5. Multiplying works. That's like this times like this equals ab. So this works. Division works too. But addition, you see that addition and subtraction will not work. A very serious warning. Don't use it. Okay. Unless they are identical. And in that being identical, what we are doing, you see this, integral root 5 plus 2 root 5. That's the step here that was skipped, which is we start by taking 5, which is common, and have 3 plus 2. So that is how we got 5 root 5. Special addition is possible when you have, like you see, now if you have 2 raised to the power n plus 2 raised to the power n, a step that was skipped here is that this becomes for us 2 raised to the power n is common. Then we have 1 plus 1 here. This now becomes 2 raised to the power n times 2. And at back we take the indices again. So this is 2 raised to the power n plus 1, the same base. Exponents numbers. What does this mean? It says when the base is greater than 1, it grows. When the base is between 0 and 1, it shrinks. negative base even so so the negative base, anything any negative number raised to even turn to positive. If it is odd, it will still be odd. So now we have opportunity to practice. Let's quickly take it. Y raised to the power 3 times y raised to the power 5 is what? Please, quick.
Where is the power 8?
Yes, thank you.
Correct.
Z raised to the power 10 divided by Z raised to the power 4.
Z raised to the power 2.5.
Minus now. I even show you now. That is 10 minus 4. Is that not? Division means minus. The same way you did the plus. So the multiplication you did plus. So that is this.
Correct.
I hope it's clearer now.
Okay.
This one. 2 times 6.
18.
Which option?
12.
12.
Correct.
Next one.
Where is the minus 2?
That's 1 over 5 squared, right?
That's minus 25.
No. Look at it. I don't know whether you're able to write something at all. See, look at it here. Is 1 over 1 over. Look at it here. So it is 1 over. Is 1 over 25.
Correct.
This is also reciprocal. Anything raised to the power just minus 1 is a reciprocal. That is, turn it upside down. 4 over 3 becomes 3 over 4.
Correct.
Remember this? You bring the 5 in. So this becomes s raised to the power 3 times, so raised to the power 1 over 5. 3 times 1 over 5 is, this is s raised to the power 3 over 5. Where is it here? The last one.
Correct.
The square root of 50. Whenever you see like the square root of a number, you start thinking about what? You start thinking about the or you think in terms of perfect squares, and you can see that the nearest perfect square to what is it called, to 50 is 25. So this is root 25 times root 2. Root 25 is 5 times 2. That is 5 root 2.
Correct.
Root 36 is 6. Root 64 is 8. 6 plus 8 is 14. Do you agree?
Yeah. Correct.
Now this is the one that is special. We just take 1 out. 3 raised to the power n. 1 plus 1 plus 1. So that this is now 3 raised to the power n times 3, which is 3 raised to the power n plus 1, because the same base. That is the first one here. Don't mind the coding.
Correct.
Minus 3 squared compared to minus 3. Minus 3 squared at least turned to positive. So it is greater.
Not quite.
Ooh.
Quiz complete. You scored 98%.
Okay. Alright, I think it's a coding problem. So both of them looks like it will have been differentiated. One means 3 squared then minus. Okay, so I assume it wasn't clear. Alright, so thank you for joining me, and we'll continue tomorrow. Bye.
Alright, thank you, sir.
You're welcome.